Well, hello everyone, and welcome back to Adrian's Digital Basement. On today's video, we're just gonna have a little bit of fun poking around at this little Sharp 13-inch television set. I wanna see if I can modify this thing to make it better than it is, because this is a pretty bog standard television, North American, NTSC only TV, readily available, easy to find here in North America. And this one only has RF input and composite video and audio in the front. So it's better than some of these really cheap little small TVs that only have RF input. But I think we can make this thing better by potentially adding S-video input with some RCA jacks and a little switch here, and maybe even RGB, maybe. So with this video, I don't really know where I'm gonna go with this because I haven't done any work really trying to figure out whether this is gonna be possible, so this might be a big bust. But if anything, it'll just be fun to poke around the insides of this TV, check it out, and then see if it can be improved. So, as usual, without further ado, let's get right to it. Before we get started, just the usual caveats I have to say before working on a CRT. This thing does run at 25,000 volts while it's operating. It's low current, but that's enough to give you a nice zap. The CRT itself is a big capacitor, so even when the set is turned off, the CRT is going to hold a charge for a while, so you need to be very careful working inside of these, especially if you don't know how to do so safely. In addition, of course, this is mains powered, and this power supply in this thing is hooked up to 120 volts or 240 if you're in Europe or anywhere else in the world. And of course, that is actually very lethal. So I'm going to be operating on this TV while it's turned on, but I know how to do so safely. So please make sure you do as well if you're going to be poking around inside one of these TVs. Now, as for this television, it is a Sharp 13J-M100 from September 1997. These things are bog standard. There are tons of these floating around, and you should be able to get them relatively inexpensively, potentially with a fault. Then someone will give it to you for free, potentially. And this one actually was given to me, and it has some kind of a fault. And let's see if we can fix that fault. And then, like I said, try to add some Chroma Luma inputs, maybe with some RCA jacks and a little toggle switch, and maybe investigate if an RGB mod is even possible. And if it's easy and possible to do, then maybe I'll do that as well. This TV is pretty run-of-the-mill. 1997, as I mentioned, means that it's extremely consolidated and everything is simplified just down to really basic components. It means they're relatively easy to work on. That Philips TV I recently worked on the second channel, that had those weird 1/4-inch audio jacks on the side. Well, basically the architecture of this TV, even though it's a Sharp brand TV, is essentially the same. Now, as far as I'm aware, this set either doesn't turn on or has some kind of fault. So I haven't actually run this thing yet. So why don't we turn this on and see what happens. And I'm going to input a video signal from my test pattern generator. Currently the mains power is off. Let's just make sure the generator is running. Yes, it is. Okay, I'm going to hit the power switch. So this has power now. And let's turn it on. Well, it started. There's high voltage. So that's good. And, well, there it is. It looks absolutely fine. I don't see any issues whatsoever. It's very interesting. And the image looks really good as well. When I had it turned around, you could see there was a little bit of soot on things. So this TV was actually used. It's not like this is a brand new virgin set. But the image looks really good, and I have to say all these late model TVs, by the time this came out, the CRT technology, you know, the way they manufactured the actual CRT was so good, they're just very, very reliable. So generally, if you have one of these 13-inch sets and if it doesn't have a bunch of burn-in on it, it's usually they're gonna be in pretty good shape. So even if it doesn't turn on and say it has a fault and you have to fix it, once you get it working, there's a pretty good chance the picture is going to look pretty good. And case in point was that Philips Mystery Jack TV. I never saw that thing run until I repaired it. And once I did repair it, yeah, the image quality looked good. But these little Sharp sets, I think this is just a much more visually appealing set to me. I guess I like the black plastic, and it's less bulbous looking, the case design at least. It's got, I don't know, just a more pleasing aesthetic to it than that Philips TV. So this is something I definitely will probably keep, especially if we can modify it by adding the composite or the S-video jacks to the side. So it's kind of funny that this thing is just working because, like I said, this was given to me and I was told that it did not work or it's got a fault. Now, intermittent faults, if this thing does have some kind of fault, could be caused by cracked solder joints on the main board. The heating and cooling cycles on those single-sided PCBs that are used on these cheaper televisions definitely can develop cracks, and then that can result in intermittent faults. But I mean, I'm not seeing anything wrong here. Everything seems fine. Looking at the geometry of the set, it's not great. And you know, it's not really something you can fix on these. If you notice, when we look at this crosshatched pattern, there's more of a gap at the top than at the bottom. And on this side, it's, well, I'd say it's possible the whole image is slightly rotated, so the whole yoke itself is turned on the back of the set. But unfortunately, these 13-inch TVs have very cheap electronics, and there will be no menu settings, at least on these brands like Sharp, to adjust anything to do with geometry. Usually in the service menu, which you can access typically on these, let's see if we can get into service menu. The way it would work is you hold down volume up and channel up, and we turn the power off to the set. And if we keep holding those buttons and you turn the power onto the set, or you plug it into the wall, it should go into service mode, turn itself on, and yes, we are in service mode now. Now, luckily for pretty much all of these Sharp sets, at least the ones that look like this, they have service manuals available online. You can find them online, and I have done that for this TV. It says S01 and 41, and this is the picture control or sub-picture. So picture is the contrast control or the white level control. So what that mean by that, let's see if we can bring up the regular menu here. I cannot while it's in the service mode. But if I could bring up the regular menus, I can go to the video adjustments where you can, you know, do color, tint, contrast, brightness. And on this TV, it's called picture and brightness. So brightness control is the black level control. So turning up the brightness will make this black square in the middle of the square look like kind of grayish. And then the picture control is how bright the white is. So if you imagine this is black, this is the maximum white. As you adjust picture control, it raises and lowers the maximum white level. And as you adjust the brightness control, it shifts the entire thing up or down. So it's moving the black level up or down. It's sort of like the offset for the entire thing. So it will make the picture brighter to turn up the brightness. Anyhow, this is the sub-picture control. So if you had the picture setting, say, in the middle on the main menu, and you turn this down or up, it will affect the overall white level, the picture level of the whole screen without moving what's in the main menu. And I'll show you what I'm talking about. So we exit the service mode. So we go into here. Oops, that's not what I wanted. We're gonna go to the menu. We'll go to video adjust. Okay, so picture control right now is maxed out. I find that on these sets, the picture being maxed out is too bright. It really is overdriving the CRT, and I guess for watching regular TV, they want the TV to look as good as possible, but for instance, hooked up to a computer and stuff, you don't need to do that. One thing you can do, of course, is you could just turn down the picture control, and if I bring up the regular test pattern here, and you turn this down, you can see the overall image is getting dimmer. The on-screen displays don't. Now, what the sub-picture control does is, imagine if we put this back all the way up here to 50, and we go back in the service mode, and I turn down the sub-picture control, that even though this is still set to 50 in the main menu, this overall picture will be dimmer or brighter. So I like to actually turn that down typically, so that way if someone sets this to 50, it's not going to be overdriving the CRT quite as much. Now the timeout is very short on this thing. Let's go back into service mode, so volume up, picture up, and turn the set back on, or powered up that is. Okay, so there's S01 is 41. So that is the picture control. This is sub tint, so same thing, but for the hue control. And then S3 is the color. I know that's gonna be harder to see. Let's turn this to something that makes it more obvious. There, blue background, a bit more obvious. So S337, that is the sub color control. So again, that adjusts the color offset from the outside service menu when you're adjusting color. S4 is sub brightness. S5 is sub sharpness, and then S6 is horizontal phase. So we'll go back to this one, and now if we adjust this, this will move the entire picture up and down. So you can see there as I adjust it, moves the picture up and down. So vertical phase with S6 is available to us. S7 is horizontal phase, so left and right. And again, we can kind of get an idea. If we move this all the way over here, I want to see what this line looks like. We can see that this line on the left side, oops, sorry, some of my remote control buttons were buffered. It is slightly rotated, meaning we can see a little bit more of the line here than we can at the top, but it seems almost like it's worse over here. Now here's what I mean. See, you could just see the white line, but it sort of disappears up here where there's just like 3 more squares. But look at it over here. If I move this where the line is similarly close, You know, we have almost 5 squares here before where it disappears. So the geometry distortion is worse in this corner. But that's a physical issue with the deflection yoke, and there's not really a way to fix that. You could try to manipulate the yoke by bending it and stuff. You might be able to fix this, but that will also affect convergence. So I really recommend not touching that and just sort of leaving this alone. This was a very cheap TV, and these were manufactured without exacting standards. It was just sort of slapped together. Whoever made this in the factory, it was going down an assembly line. They just had it plugged in, turned on. They put the deflection yoke on there. They kind of bend it, put it in position, tighten everything down. They probably spent like 10 seconds putting this TV together and getting the geometry dialed in. On something like a VGA monitor or a high-end television, they would spend more time dialing it in. These people are highly skilled about getting the yoke in the exact right position and putting little magnets into the right spots and getting the convergence just right. This TV, the convergence looks pretty good. It's slightly off on there. It's actually quite good, the convergence, so it's not something that I would even adjust, because if you don't know what you're doing, it's very easy to make it worse. So S7, as I said, was horizontal phase. Then S8, that's the RF AGC, or automatic gain control. This has to do with the tuner, so you just leave that alone. S9 is the vertical amplitude, so this, again, is the height. You can control that. So we can shrink this down, and now you can start to see like the top and bottom of the image has a black line there. S10 is the VCO, or voltage control oscillator. This has to do with the tuner again, so there's no reason to touch that. And then we have cutoff controls. S11 is cutoff. So red cutoff is set to 0, 0, and it looks like that's the default. And then we have green cutoff. It's also set to 0, 0, so that's also the bare minimum. And then we have the blue cutoff, also 0, 0. This is, I'm looking at the thing back here, and those are the default values. Then we have S14, that's the green gain, or the drive control for the green cathode. And then we have S15, which is the blue gain, or the blue drive. These settings are there to adjust your grayscale linearity and your color balance. It's very typical for the drive controls. You don't have a red drive, or you don't have a green drive. You might have a blue and a red, or this TV has a green and a blue. It's just typical. You adjust around them using red as the default on this TV. Now I gotta say, with this TV, looks pretty good. I don't really see any issues. I don't know where these settings came from, but I'm gonna say everything looks pretty good. The next control, S16, according to the service manual, is the trap, and it's either 0, 0 or 0, 1, and it was actually set to 0, 1. So what this is this trap is a 3.58 megahertz trap. Essentially what a trap is, it's a notch filter. So it's filtering out the video signal that's coming into the TV right at the 3.58 megahertz spot. That is where the color information is stored in the video signal, in the composite video signal. So it will lower the resolution of your set. And we can actually see this in action if I switch over to this other input right here. This is coming from my signal generator. And what this input is this is the YC input. So this is monochrome only. It contains no color information. And these various lines represent higher and higher and higher frequency. Well, we can just see that there are lines visible over in this area of the picture. And this is with the trap set to 0, 1, which is disabled. If I turn on the trap by putting it to 0, 0, notice the lines disappear over here. They're sort of visible over there, but this one is now just gray. That's because this band exists right in the 3.58 megahertz range, and turning the trap on filters it out entirely. Now, I'm presuming there's going to be other filter circuitry inside the TV that's actually filtering out even the higher frequency stuff as well. And to get really good performance over S-video input, or YC, we're going to have to disable or bypass that filtering. But one of the things you're going to have to do is turn the trap setting off, which is the 0, 1, S16 0, 1 on this sharp set at least. It's going to be different on every set. And that gives us the additional sharpness to show these lines on this part of the set. Now it does have a side effect, if we go back to color by swapping the cable over, that you will get a little bit more artifacting. Now, because this band exists right in the 3.58 color carrier information, it's causing this blue stuff to appear. Now, if we turn on the trap, I mean, all it really does, it doesn't really get rid of the color banding, because that's just part of the way NTSC works. It just kind of takes away a little bit of some extra dots that are visible in there. Now, keep in mind that a PAL television will have a similar trap, but it's going to be at 4.43 megahertz, which I think is what this band is right here. And that's because the PAL color carrier is encoded at a higher frequency than it is an NTSC. So it would just be affecting this bar as opposed to this bar. And each one of these bars is a lower and lower frequency. It's just showing you the frequency response of your television. Now, one side effect, as I just mentioned, about having the trap turned off, which it is right now because it's set to 0, 1, is when we look at the color bars, I can just make out a little bit of the dot pattern that is the color information itself visible within these solid color sections. If I turn the trap on, it gets rid of those. So now this just looks like solid magenta, solid red. When I turn it on, I could just subtly make out some dots. But you know what? I don't mind that, and it will increase the resolution ever so slightly, especially when you hook up something like an Apple II and you're outputting monochrome text to this thing. The color decoder is not even enabled, so having the trap turned on will potentially make the text less sharp, and turning it off by having it set to 0, 1 will make it sharper. So this is one of the improvements you can make on pretty much all these TVs. If you go in the service menu and you see a trap setting for 3.58 megahertz, disable it, and that will cause a little bit of dot crawl, but then you will get sharper text, especially over monochrome inputs on the video input. All right, well, we've been looking at the TV for several minutes here, and there hasn't been any issues. It seems to be working, so I don't really know what this supposed fault was with it. But I guess what we should do is probably turn this thing off and take a look at the main board and just try to see if anything is obvious on the main board, because we might be dealing with cracked joints, and whatever fault this thing has just hasn't shown up because, you know, the heating, expansion, flexing of the board hasn't made that fault appear. For discharging CRTs, I like to use my high voltage probe. Now, these things are kind of expensive now. I happened to get this like years ago, back when they were still dirt cheap. What this is this can actually measure the voltage of the set while it's running and can tell you up to 36,000 volts what the voltage is. But what I like about it is great for discharging the CRT as well, because it gives you a visual indicator of where the voltage is, and you can see it drain down. So to use this, you have to clip this onto the negative side, which happens to be the outside of the CRT. And I'm holding the button to the on position, and I'm sticking this inside. And actually, you know what? There was no storage charge on this set at all. Now, a lot of these TVs do not self-discharge. You turn them off, and this will be sitting here at 25,000 volts, and you'll see the meter go down to 0. It takes maybe a couple seconds. This one was already relatively low. It looks like there was maybe a couple thousand volts stored in there, and then it quickly drained to nothing. Now that I know it's safely discharged, I'm just gonna use a little plastic spudger here just to get the clip off of here, like that. Now, one thing about a capacitor or even a battery is when you've discharged it and you take away the load, which would have been something like the meter, it can actually charge itself back up again. So it is not unusual for potentially a couple thousand volts to sort of reaccumulate at the anode connection. And that means while you're touching this, even after you've discharged it and unplugged this, you could still get a little bit of a shock from there. So while you're working on the set, just don't touch the high voltage anode cap. Even after you've discharged it, you just get a little bit of a shock. Or you could take a clip lead and just clip it onto that and clip it onto something on the edge of the CRT, like the metal part here, and that'll keep discharging it indefinitely. All right, so I'm just gonna pop this thing apart, so we'll pop off the neck board. And yeah, there's a good amount of soot on stuff here. So this TV was definitely well used, which is good to know. I always like to know that electronics were used and they weren't just, well, basically used a little bit and then became faulty and turned into junk pretty quickly. I do find that these little TVs are pretty reliable. They don't generally seem to have issues. The topology of this board is going to be just like that Philips Mystery Jack TV. So we have the Jungle IC here. There's a microcontroller. It's probably on the bottom side surface mount. There's a small little package up here, which is probably going to be the EEPROM for storing settings and parameters or whatever. Flyback transformer. We're going to have horizontal output is going to be on this heatsink. There's the little drive transformer that drives the horizontal output. This is going to be the vertical drive right there. The tuner is down there. There's going to be a small IC on here somewhere. It's an audio amplifier. I don't necessarily see it right now. And then this is going to be the mains power supply. And this large heatsink is probably going to be something to do with the power supply. Maybe it's a linear style power supply. Although this is an isolated design because there's a white line to tell you that this is the hot section, AKA this is reference to the mains. So that means it's the lethal section right here. The fact that this has the video input jacks on the front mean that these metal shrouds here are going to be referenced to the ground rail on this isolated side of the set. And if this were referenced to the mains and you had the AC jack plugged in the other way or your outlet was wired wrong, then theoretically this could be live at 120 volts. So that's why these later sets always use an isolated power supply design. Looking at the bottom side of the board, there's our microcontroller. That's going to be generating the on-screen displays, the closed captioning or subtitle decoding. That would be potentially outputting an RGB signal that goes to the main Jungle IC. On some sets, the microcontroller and the Jungle IC is integrated into one. That means you cannot potentially inject an RGB signal. But on many sets of this time period, they are two separate chips. The only caveat is some of these microcontrollers output a TTL RGB signal. That means it's 5 volts, 0 to 5 volts, and therefore analog RGB isn't necessarily something that can work with these Jungle ICs. We'll have to check the schematics to see if we can figure out anything and maybe find a data sheet for the Jungle IC to see if we can find out details about how that might work. All right, so first things first, what I'm gonna do is I'm gonna do a quick and close inspection on the bottom side of the board, looking for any cracked solder joints or any cracks in the PCB. When you have reported faults or intermittent faults, it can easily be a crack in the board or cracked solder joints, which is more likely gonna be the case. This TV doesn't show any signs of physical damage, like it wasn't dropped, but if it was dropped, then quite likely you have cracks in the board that can cause intermittent faults or just cause it not to work entirely. I fixed a lot of TVs and monitors over the years that had cracked boards, and you just have to jump over the broken traces and put some glue there to kind of reinforce it. But in this case, I'm going to do a quick inspection and look for any cracked solder joints, especially on all the large through-hole components. For instance, the connectors that go to the deflection yoke, then things like the horizontal drive transistor, the vertical output transistor, the tuner, flyback, all the things that have the big pins. You just need to check to make sure that you don't have broken joints, and if you do, you want to reflow those. Or if you're not sure, just reflow all of those types of joints just to make sure that it's solid. Okay, I've gone over the board. I gave it a good dusting, so that's why it looks a bit cleaner. It was luckily not sticky dust, just came off very easily with a brush, a small vacuum, and then I just blew the rest of it off of it. I went over all of the through-hole connections on the bottom for the larger components. Everything seemed totally fine. I didn't see any cracked joints. I still reflowed stuff to the large things like the flyback, but the fact is that this thing has a reported fault and I haven't seen the problem, and I didn't see any physical manifestations of the problem is a little bit concerning. Specifically, that's because when you flip the board over, there are so many surface mount parts on this thing, and I think I've had issues before on some of the other sets I worked on. In fact, the Philips set had it where it had a bad, tiny little surface mount component that was making a bad connection or whatever. I think it was a termination resistor. So when you have problems like that, they can be extra hard to track down on boards like this. So hopefully if there is a fault, it manifests itself so that I can start to figure out exactly where it is. What it's time to do now is let's jump over to the service manual and start to try to figure out if any kind of mods are possible on this set. And let's try to understand how this thing actually works. Now keep in mind, if you are working on a set and you don't have the service manual, pretty much everything I'm going to be doing here is the same. It's just you're going to have to do a whole bunch of reverse engineering just to try to figure out the way all these chips interconnect with each other. And also you're going to have to probably try to look up the data sheets for the ICs that are on the set and hope that you can find them. Because if you do, that's going to give you clues as to what inputs and outputs are available on all of these chips. And you can see if you can inject signals directly into them. Now in this particular set, we have IC 2001, which I happen to know is a microcontroller, and IC 201, and that is the Jungle IC, the one that's actually taking the video signal and processing it and converting it into RGB signals that go directly to drive the CRT cathodes themselves. And it also generates the horizontal and vertical signals that go to those drive electronics to generate the high voltage, to generate the deflection. It's basically a lot of what was the complexity of a TV is simplified into this one single chip. Now, the thing about these late model TVs with these chips is they are controlled with I2C. It's a communication protocol that allows, well, a microcontroller to control all the various aspects of this chip. So when we go in the service menu and we adjust those drive signatures and the position and whatnot of the image, that's all happening over an I2C connection between the microcontroller and this chip. That unfortunately can mean that there are features of the Jungle IC that are there, but they're not really accessible because the microcontroller is programmed with a mask ROM internal to it that controls the Jungle IC with that I2C bus. So for instance, there might be an additional video input or an additional RGB input on the Jungle IC that we can't necessarily access because of the I2C communication that's happening between these two chips. We need to alter the programming on the microcontroller or try to drive the Jungle controller ourselves using something like an Arduino to access those extra features. And the only way you can know about those features is if you can look up the data sheet for the Jungle IC, and it will list all the commands for the I2C bus so you could potentially control it yourself. Now this service manual right here has the functional block diagram of the way this set works, and this is a good place to start. So this middle IC is the main Jungle IC. We have the tuner up there. This little board is what plugs into the back of the CRT. This is the neck board. We have the audio amplification there and the speaker. IC 2001, that's the microcontroller itself, and then down here is the power supply that powers up the whole set. It generates the B+ voltage that then powers everything. Vertical output IC, that's 501. We have IC 2040, that's a reset IC. We have IC 2101, that's an EEPROM for storing all the settings. The part that's attached to that large heatsink that I said was part of the power supply is going to be this 130 volt regulator, IC 701, bridge rectifier. And we have the horizontal output transistor, which is actually what drives the flyback transformer to generate all the high voltages and the horizontal deflection. In fact, it looks like that 130 volt regulator is used to generate the B+ that specifically goes to the flyback and is pulsed using the horizontal output transistor. So this is on the hot section of the set. That's interesting. That's a little bit of a different design than I've seen typically on like that Philips set, where the B+ was generated by the power supply, a switch mode power supply, and all of the horizontal output drive stuff was happening on the cold side, the not mains reference side of the set. But everything inside this box here is mains referenced, aka is potentially dangerous to touch unless you have an isolation transformer. The horizontal output transistor, the big one that's switching at 130 volts on and off to the flyback, is actually driven by a little transformer and then a little transistor that takes its signal from the main jungle IC. Jungle IC takes the video signal and separates the horizontal vertical sync, and that drives the vertical output, and then down through these components, the horizontal output. And then for the voltages that drive the actual set, looks like the mains just goes through a small transformer. It might come in 120 volts, come out 12 volts, for instance, go through a bridge rectifier, and then a regulator, and it says 12 VA. So that 12 volts then goes through a relay, which can be turned on from the microcontroller, which then goes and turns on the 130 volt regulator, which then powers up the flyback transformer, of course, through the horizontal output circuit. The 12 volt rail that's generated by Q751 is then brought down to 5 volts through another regulator. It says D102, so that may be as simple as just a small Zener diode that brings it down to 5 volts, which seems to run the microcontroller, the EEPROM, and the reset circuit. There's additional rails on the set, 9 volts and 12 volts, but this is not generated by the mains transformer. This is actually generated, if you follow this trace all the way back to the flyback and see there's a 12 volt output with a diode. That means that only when the set is started up and running do these voltage rails appear. These are going to be used most likely to power up the sound circuitry, but also to power up the jungle IC. Typically, the jungle IC is not powered from the mains power supply. It is powered by the flyback actually running. But you might be asking the question, well, how does that work? Because how's this going to get power if it's generating the drive signature for the flyback? Well, there's a little bit of a starter circuit right here. It says Q753 horizontal starter, and I think that's driven by the microcontroller itself. So the microcontroller will generate a little bit of a signal, like 15 point whatever kilohertz, that's going to start up the flyback, and it's going to start generating voltages, which then powers up the jungle IC up here, which then takes over and takes the video signal, or generates, actually it has a free running oscillator, so it's going to generate its own horizontal and vertical output to start deflection up and everything, and that takes over from the microcontroller, from this little starter circuit. Now, when it comes to RGB, we can see that the microcontroller outputs an RGB and a blanking signal that makes its way over to the jungle IC. It says analog RGB, and then that gets converted into the RGB output that makes its way to the CRT neck board, and that's up here. But you have to be careful with these designs, is sometimes the output from the microcontroller is TTL RGB, meaning 0 to 5 volts. It's just on or off. And the inputs on the jungle IC are configurable by commands that are sent from the microcontroller to tell it whether it's going to accept an analog RGB input or a digital input. Now, it says analog RGB, but that could easily just be the conversion circuitry that exists inside this jungle IC. So we're going to have to do a little bit of poking around, maybe looking at data sheets to try to figure out what exactly is going on here. Now, when it comes to the composite video signal, well, there's a few things that are happening here. We can see audio and video input are separate jacks, and the video in, which we care about, goes into the jungle IC. And notice there's a switch there as an A and a B position. Well, one position is actually the video input, while the other position is for the TV tuner. But the funny thing is, it's not like the TV tuner is just generating a composite video signal. It's actually generating a sort of RF signal, but at a much lower frequency than the normal channel. So whatever you tune to on the tuner actually just outputs another RF signal at an IF, or intermediate frequency, which is like 45 megahertz or something like that. And that's what actually feeds into the jungle IC. That's this connection right here. Now, when you switch over to the TV tuner as opposed to the video input, and that's a command, by the way, that comes from the microcontroller, well, notice if we follow this trace, it actually goes out of the chip on pin 37. It doesn't even go to the tuner. Well, if we follow this backwards, it goes through a couple buffers and a trap, and then it goes back into the jungle IC on pin 47. What's happening is this intermediate frequency RF signal that comes out of the tuner goes into the jungle IC on pin 7 and 8, and it is processed internally by the jungle IC and converted into a normal composite video signal, and it comes out of the jungle IC on pin 47 only to be buffered and then go right back in on pin 37 and then go through that switch. And when the switch happens, it comes out, and I'll explain that in a second. So theoretically, if we did not have a composite video signal available on this TV, it was RF only, you could potentially inject your own regular composite video signal into the TV by injecting your own video signal right here into pin 37. So you would set the TV to channel 3, but instead of seeing the tuner, you would just be looking at an external video input, because it's basically wired up exactly like this. And the I2C command from the microcontroller tells it to switch between pin 37 and pin 39 for the video inputs. Now, the reason why you see this trap stuff in here is because this output on pin 47 is not just a normal composite video signal, it has the audio information mixed into it as well. So that's why it comes out, goes into this buffer, and is split off and goes over to this section, and there's a bandpass filter, 4.5 megahertz, and that's for the audio, and it makes its way back into the chip on pin 52, and then it runs into an FM detector. And FM is the type of audio that's used on NTSC television, and what that does is then it generates the audio signal, which somewhere on here, let's see where that is going. It's probably internally connected between there and here, and then it switches this between pin 55, and we follow 55, that's the audio input, and this right here, which is not connected to anything, but I bet you that's connected to the FM detector, and that comes out pin 2, makes its way to the audio amplifier and to the speaker. So the funny thing is, with all of this in and out happening on this jungle IC, that's just typical, and that's because back in the day, all of the various components that were happening in the jungle IC used to be discrete chips or even circuitry on the TV, and they essentially combined it all into this one chip, but they retained a lot of the functionality of it coming out and coming back in, just so you had as much flexibility as possible at using this in your design, allowing you to kind of simulate the fact that you used to have all these external components, because maybe you're going to be doing some extra stuff like switching between 2 different tuners or whatever. It just allows that flexibility. So none of the components inside this jungle IC are kind of connected internally for the most part. They're all having to come out and then go back in again. So going back to the video input, remember we have a video input that comes through here and it goes to that switch, so it's either TV or external. And notice it doesn't just go into the chip and then come out as RGB going to the CRT. It actually goes out again. It comes out of the chip on pin 41, then it goes through a buffer and it goes back in as a Y input. Now Y as in YC or Luma Chroma. So this chip actually does support S-video, and the video output comes out, it goes through a buffer, goes back into the Y input or as a Luma input, and it also comes in, because there's that buffer right here through this capacitor, into the C input, which is Chroma. And it has a BPF or a bandpass filter that's going to be filtering out that lower part of the video image, all the Luma information, because remember Chroma is at 3.54 megahertz, so all it really needs to look at is that, hence the bandpass filter. And then this YC input, this clamp sawtooth, and the BPF is what's connected to the analog RGB. There's a switch in there to switch between whether it's that input or it's this RGB input, which is for the on-screen displays. And then that goes through the cutoff driver out to the CRT neck board, which is up here. In addition, the contrast brightness processing is happening inside of here. Not to mention at some point, I don't even know where it's happening. It's probably the Y input, then the HV or the horizontal vertical processing is happening. That means it's extracting the sync information, and that drives the various horizontal vertical deflection and all that kind of stuff. Most jungle ICs work pretty much just like this, unless it's the later versions which have the microcontroller all integrated into it. Generally, they have all these ins and outs, allowing you to potentially inject signals directly into it. So one thing I'm thinking here is for adding S-video or Luma Chroma input to this TV, well, one thing we can do is we could potentially take these 2 inputs and put a switch, a little toggle switch like this, and switch between the normal buffer and the output, the YC input that's coming through this chip the way it is now. That's one position. And the other position is just us connecting directly a Luma Chroma input right into this chip. Now, this is a block diagram, so there's going to be a lot of missing components and stuff that are happening on here, just these blocks. But the service manual has schematics to allow us to look more in depth into how this works. Now, incidentally, the Commodore 1702 monitor has a switch on the back for separate or composite video, which is like YC or composite. it works exactly like I'm describing. That switch there, the signals all run through it, and the chips that are on that monitor doesn't have a jungle IC like this. It has discrete chips, but it's literally working exactly like this. What's happening is the composite video goes in, it gets turned into YC just like in this, and it goes back into another processor chip that turns it into RGB to drive the CRT, and they put a switch in line to switch between essentially the separate YC input and composite video. So we'd be really replicating with this little toggle switch and then a couple jacks on the back of the TV how the Commodore 1702 is, if this is possible. And that's all there really is to it. All these TVs work essentially the same way. One of the negatives with these types of sets is it's all surface mount. There's tiny little components on the bottom. So there's going to be a whole lot of trying to see very, very close up exactly how things are all interconnected, but it's still quite doable. So let's keep scrolling down. We should be able to get to the actual schematic. Here it is. That's going to show all of the components that are happening. Now this scan is not the best quality, but we can kind of make out some stuff. So I think the first thing I want to do is I want to start poking around with the YC stuff. Now we need to find that on here. So video output comes out, and remember this is a composite video signal, so it's got color and the luminance information combined together. It goes into this little bit of circuitry here, and almost certainly this is a filter to try to filter out some of the luma information before it goes back into the chip, into the chroma input. Plus it's a bit of a voltage divider as well. So we need to kind of look at what voltage level is going into here. I don't think it really necessarily matters. Chroma information, the amount of color is not derived from the voltage level of the chroma information. It's how intense the pattern is, the alternating dot pattern. So no dot pattern, no color information. Strong dot pattern, you have color information. But this is probably some kind of filtering that just filters that out. Even though inside the jungle IC, we saw there was a bandpass filter as well. So it also has circuitry. But this is stuff we would necessarily leave in place for the stock video processing. But if we were going to inject our own chroma signal into it, we'd want to inject it somewhere like right here at this point, because the information that's already on the chroma information we're going to be injecting in theoretically should already be processed correctly. You know, it doesn't need this extra stuff, these inductors and things like that. So we'll have to play around to see like the best point to inject it. But yeah, I'm thinking just right there at the connection of R806, I guess, and C807. And then for the Y input, that's up there. So this comes out, it gets right there to that junction. It goes into this little circuitry here. It has this buffer Q404. So it's a video buffer, and I bet you it's doing that because it's trying to alter something about the level or change the video signal in some way. Almost certainly, this is filtering the signal and smoothing it out to some extent. And then the Y input is this number 3. It is picked up there, goes through a small little capacitor, and then it goes into the Y input. So theoretically, if we're going to be injecting our own signal, we would probably do it right there. We'd break that signal, or we disconnect it, inject our own Y signal in, and then we could switch between stock, where we would leave that connected, or our own signal when we're going to be doing our own YC. So that's probably where we're going to be injecting it. Although, also, we could try injecting it into the base of this transistor also by breaking this connection right there between R419 and 423 and injecting it there. A lot of times it's hard to know exactly where you need to be injecting stuff. It has like these voltage levels, like 2.2 volts. A luminance signal we're going to be injecting is not going to be that high voltage. It's going to be more like, 0 volts to 1 volt peak to peak. So it may not work properly going into the base, and it's possible we need to have it go into the chip more directly, like into the right side of C410. It's hard to say exactly. You just have to kind of play around, unfortunately. And to facilitate that, you often have to like remove a component or two from the board, or lift a component, or cut a trace or whatever, so you can inject your signal just to kind of see if it's going to work properly or where the best spot to inject it into is, and then try to restore it back to the way it was so you could install your switch. So hopefully that explainer helped you understand a little bit about the way this stuff is going to work and how I'm going to try to approach this. What I need to do now is I'm just going to play around and start removing components and try to inject the video signal into the set just to find the best spot to do it. And then I might have to tweak values with voltage dividers and stuff like that. And I can use little adjustable pots to kind of get that dialed in exactly. I think that's what I'm going to do first. And unfortunately, there's just a whole lot of trial and error here, so it's not really worth me showing that process. I'll just do it and then come back and explain exactly what I did and what process I went through to get there. All right, I am ready to show off my first experiment. So I have an isolation transformer with the TV plugged into that just for extra safety, because I had to probe around on the set while it was turned on, and the power supply, as we saw in the schematic, is partially live. So we'll turn on the TV. Now currently, It is plugged into an S-video source, but we see we have a black and white image because only the Luma is connected up, and it's this little generator over here that's just generating this. So we're getting monochrome signal, as we would expect. Now this is the chroma signal that's coming from the generator over there. And I have this extra little RCA jack sitting off to the side here. And let's plug this in. There it is, chroma. And it's looking really good. It's very saturated. It looks correct. Now this isn't the best test pattern generator because I can only generate this color bar pattern, and that's it. Now currently I have the chroma disconnected from the C input in the jungle chip, right, where it loops around and goes back in, and that's where I'm injecting this chroma signal. And of course it's going to be hard to see on camera, but there is no dot crawl or anything weird happening at all. It looks completely fine. Now what I need to do is I need to disconnect this generator and hook it up to my Tektronix, because I can change to different test patterns and we can look at the high resolution tests to see if we're getting any dot crawl or anything else weird like that. So let me do that swap. And there we have it. This is the true test of an S-video input on a monitor, because this top one here, which of course are those resolution patterns with that being the 3.54 megahertz, there is zero dot crawl or anything weird happening in that, and yet we still have a nice color image on the rest of the monitor. And that's the key thing for S-video. This would be all dot crawly, as we saw before when I had it hooked up, and now it's freaking not. So it looks awesome. Now one thing I can do is I can turn up the sharpness a little bit to try to bring out a little extra resolution over there on the left side, that high frequency stuff. So that would be for displaying 80 column text, for instance. And remember, this is only possible that we can even see this stuff at all because I have that trap disabled in the service mode. So I'm gonna say that this looks freaking awesome and pretty much as good as I could expect from a monitor or a TV like this to display S-video. It's never gonna be super sharp. The CRT and the electronics just aren't designed for really high bandwidth video. But honestly, this is so much better than it would have been hooked up through composite. And if you hook up a game console this way, you're just not gonna get any of that dot crawl, and it's gonna look really, really good. So let's talk about how I did this mod and what I ran into problem-wise performing it, because I had to try a few different things before I got it to work like this. So first thing I did is I printed out the little section from the schematic that showed the video out and then the YC input, just so I could understand which components were actually on the board. And I used some highlighters, of course, just to help me recognize all these different components and how they relate to each other. So video out comes out of the jungle IC, and it's processed through this buffer for the Luma side, and then it makes its way to the Luma input, the Y input in the jungle chip. And then the chroma splits off there and goes through this stuff and comes into the C input, or the chroma input. Now what I found is that a bunch of these components actually aren't installed on the board. So NI not installed, not installed, not installed. There's a resistor jumper, so it's just a small jumper that's there. Doesn't really do anything other than jump over another trace. That goes through resistor 440, it goes through this capacitor, and then there's resistor 806 connected to ground, 33K, and then that goes into the input. So the way I ended up hooking up the chroma input, and this is it right here, and yeah, I broke this off a spare CRT board just so I could use an RCA jack because I had to install a couple of components onto it, is I removed C807, that capacitor, then I connected the chroma input from that little board right to this point there. So it goes into the chroma input. I actually left R806 in place, 33K, because I figure it doesn't really matter. Since these parts aren't installed, we can kind of just ignore this whole section. It's not even there on the board. So simply removing C807 had the effect of completely disconnecting the entire chroma output from the video output signal, since these other components aren't there. I don't know what they would have done originally, probably some kind of filtering or bypass or something, but they're not there, so it doesn't really matter. Now what I did not do is just take the chroma input from my pattern generator and just feed that directly into this point. Here's how it actually works. So this is going to be the RCA jack. The outside of the RCA jack is connected to the same ground as all of this stuff. And then the input, or the inside of it, goes through a 75 ohm resistor and then a 0.1 microfarad capacitor, also known as a 104. I just use a little ceramic one. So it's terminated. Oh, I'm sorry, this is not actually there. That is my bad. the 75 ohm goes to ground. So this is where 75 ohms is. So you got to terminate the chroma input, just like the video signal, to ground through 75 ohm resistor. And then this just makes its way through a 0.1 microfarad 104 capacitor into this point. So when I was demonstrating the chroma, that's exactly how it was working right now. And it was totally working. So we take a look at this little board. There is the capacitor, and there is the 75 ohm resistor. So that's all there really was to it for the chroma input. And to basically switch between this original chroma output, if we're going to use composite video, or the external chroma input, all you do is just use a single toggle switch and add this little tiny surface mount resistor, 82 picofarads. Boy, I'm terrible at doing these diagrams, but we just put them up here to a little toggle switch. I don't know, that's what I'm going to try. So up or down, we'll just connect between the external output or this internal output and then feed it back in the jungle chip. And that's all we really need to do. Now, I talked originally about potentially not using this whole buffer, or maybe like inserting the original video signal there or something like that. Turns out we can't do that. Typically, when these sets have these surface mount tiny components and really hard to see traces, what I end up doing is take a photograph of it, and then I use something like GIMP to actually draw out all the various traces and the various components, because where they're located on the schematic doesn't necessarily have anything to do with where they're actually on the board. So as an example, here's the chroma input, pin 45, and remember it shows resistor 806 connected up to ground. Well, you might think from the schematic that it's over near C807, that capacitor. But the reality is it's not at all. Here's pin 45 and there's R806. That's that little 33K resistor to ground. It's over here on this side, but the other capacitor that I removed from the board is actually this one, C807. So that's what I removed to disconnect the chroma output from the rest of the set and inject my own chroma signal. Now I ended up just attaching the wire, I think, to this pad right here to inject it into pin 45. But that was that tiny surface mount capacitor that I removed. It was kind of difficult on this set to figure out exactly like which markings went to what component, because stuff is kind of all over the place. Like you might think that that component is RJ8, which is a resistor jumper, but it's not. RJ8 is, I think, that one, or maybe not. Okay, because like this component with the box on it is actually R441. I think this component that's not installed is C421. I don't know. It's kind of all over the place a little bit. So I drew these boxes on things just to help me figure out what's what. So that box there is R440, which was on the schematic. And this one here is R441, which is on the schematic, and C807 is on the schematic. But you can see that the trace goes through a bunch of stuff here, and there's stuff missing on the board. There are guard traces, by the way. See these extra traces? Like there's a trace right here that goes nowhere. That's a guard trace. So that has a ground on it. And they do that to try to prevent crosstalk and interference between like chroma and video signals and stuff like that. So all these extra traces in the middle, like this one there between these two highlighted blue traces. Let's zoom in a little bit. So this one right here, that's a guard trace as well. Because you can see it just kind of goes down here and ends. So that's what Sharp was doing to kind of prevent interference. And it worked pretty well because the set doesn't have any interference. Nice, clear video signal. Anyways, to kind of go over the way this works, just so you kind of understand. So this is the video output pin 41. So this is what's coming out of the chip. And it makes its way all the way over here. It splits right there. It makes its way up over here to this component. Green indicates that it's simply a jumper. It's a resistor jumper. That is not a resistor, it doesn't have a value. It looks just like a resistor, but it's like a 0 ohm one. And that connects us to R440, R443, down to the little capacitor, and then back down to the chroma input. So this whole section here with these three components, that's the chroma input back to the jungle. But for the Luma input, it actually goes through this resistor jumper, and then the trace goes over here, touches this pad under that component, loops around here, goes through another resistor jumper, simply there to jump over this other trace. And then it makes its way to that component, which is R410, I think, which, 418, that is on the schematic, 1.5K. And then that goes over here through another resistor jumper. It goes to that component. I don't think I mapped all this out because it didn't really matter necessarily. It makes its way over to this little Q404, and that's the little buffer that we saw on the schematic. Anyways, the output of all of this is it makes its way through these components back to here across this green thing, and it looks like a resistor or something with a squiggly line. It's just a jumper. That's all that was actually there on the board, even though it says R433, although Maybe that's that component there. I don't know. Anyways, it didn't really matter. It was a jumper link, and that makes its way back to here over to pin 43. That's the video input. So it didn't really match the schematics exactly, but it was close enough for me to kind of figure out how this all worked, and using GIMP was absolutely essential for me to figure it out. So what I tried doing first was injecting the Luma signal from the test pattern generator into the video input on the jungle IC. This was pin 43. That was the Y input, right? So what I did is I removed this jumper link entirely. I just took it off the board, and then I injected the Luma signal here on the right side. So that just had the effect of going directly down into pin 43, which was the Y input on the jungle IC. And I was going through that little board that I showed a second ago, the one that I broke off the other CRT. So it had a 75 ohm resistor, and it had a 0.1 microfarad cap as well. That didn't work. It turns out that this jungle IC does not process the sync on the video information that goes into the Luma input. Let me just get my bearings here. So there's the Luma input, pin 43. That's where I fed the signal from my external source into this chip, and that was what the TV turned on and running. Well, it didn't work, and well, I saw an image, but the problem is that it was all skewed and it was rolling. And that's because the TV, when it has no sync input, it generates its own sync. It's a free-running oscillator, so it generates like a 60 hertz or vertical sync and some kind of 15.7 vertical sync. But when I plugged the video signal into the Y input, it wasn't pulling the sync out of the video signal, it was just ignoring it, and it was just processing the Luma. So I'd see the Luma signal on the test pattern on the TV, but it was rolling, it was all skewed and stuff like that. It turns out that the TV video input and the external video input, remember how they're switched on the inside? We saw the block diagram. It must pull the sync off of those there. It doesn't pull it off of the Y input, it pulls it off of these directly. So me feeding the Luma directly into here didn't really work, because you need the sync information for it to work. Now, the reason why I was even going to try to do that is because I had a feeling, maybe a misguided feeling, that this whole video buffer circuit up here, this is what's processing the Luma signal and then sending it back into the chip, has some kind of filtering going on. Because you see how there's like this inductor, I don't know, capacitor here, like some kind of filtering is actually happening. I should look for those and see if they're there and maybe remove them. They potentially have the effect of softening the image, just rolling off the high frequency information. And I want that high frequency information to get through all the way into the entire system. I don't want it filtered out. Now, what I ended up doing to kind of see another example of a monitor that has switchable S-video or not S-video input is I just went to the Commodore 1702 service manual. And I looked at this before to kind of see how the whole S-video input works on it, or Chroma Luma input. And let's go to that section, because I thought that there was more filtering happening on the composite video on the Commodore 1702 than actually is happening. So up here is the whole video input rear terminal. This has the Luma input, the Chroma input, and there's the front video input. So that's the composite video. And I mean, long story short, these are a couple switches that happen when you flip the one switch on the back. It's actually moving several sliders here. And what ends up happening when you're switching between Luma, Chroma, or just regular composite video, the only filtering that actually happens is right here. We have a 3.58 megahertz trap, and this transistor right here, which is controlled from the switch on the back of the monitor between Luma, Chroma, or composite video, turns this trap on or off. So when you're turning on Luma Chroma or separate mode, which should be higher resolution, all this has the effect of doing is turning on and grounding this trap, which just bypasses it. So this contrast amp thing here with this subcontrast control that goes through this 3.58 megahertz trap, well, when this is turned on, it just bypasses it, because it won't go through here if this is turned on. It's just conducting. I thought there was maybe more filtering that was happening somewhere else in the monitor, but there really isn't. It doesn't at all do any other filtering. So looking at this gave me the idea that on this TV, the fact that we already disabled the Chroma trap, we did it in the service menu, means that I could just feed the video signal in just through the standard front video jack, or the Luma into the front video jack on the monitor, and then feed the Chroma in externally and switch to that, and we'd have a reasonably good image, at least similar to the Commodore 1702. But that does bring up the question, is C419 and L406 on the board? Because if they're actually there, I should remove them. And that will have the effect of making the composite video sharper as well, which could potentially make the dot crawl worse if you're looking at regular composite video. But I think that's a trade-off that I'm willing to make just to have clearer, higher resolution S-video input on this TV. So the real question is somewhere in this mess, are those two components we're looking for C419 and L406. Here's C419, the marking is there. Where's the actual component? It's supposed to be 33 picofarad, so it'd be a tiny little cap. Like it could be that one actually. Let's see, no, I just have to see how it's connected. Okay, so C419 ends up making its way directly to the base of the transistor. That's the base. So that might be C419 right there. Yeah, that's got to be it. It would be in parallel to the inductor. So if this is the inductor, let me get a new color. So we're going to draw with purple. So this, I'm pretty sure, is the inductor. I think it's L406. And this, I'm pretty sure, is the capacitor, which has the marking all the way down here. And these are in parallel, because you see it has that trace there, and this is connected right there. Okay, so I'm going to try removing those, and we need to see if it makes the image sharper. Because that's my hunch, that this will sharpen the image if I just remove these. Or it will make it sharper all the time. And then just to reiterate, this is C419 right there, and that's the inductor. So I can just lift one side of this up, and then I have to remove C419 from the board. And I want to see if what that does exactly. What will it do? I don't know. So I went ahead and removed those two components, and hilariously, the inductor broke. One of the legs, even though I was on the underside of the board, I desoldered it, and I'm like, why is it so wobbly? And I looked on the other side, yeah, it came off the body of the inductor. So I guess I don't have an inductor anymore. I mean, I can go find a spare one if I had to put it back, if it's catastrophic, what it ends up doing. So let's see together what happens. I'm going to turn on the power, turn that on. Now, I do not have the chroma hooked up, only the luma, but let's see how this looks. Huh. Okay, well, if anything, it's really, really dark. So it doesn't, yeah, we lost a lot of the picture brightness, which I guess kind of makes sense because some additional of the video signal was going to be making its way through those components, at least the inductor, and now it's going through a 4.7K resistor to the base of that transistor. But I have to say, without a doubt, that was absolutely filtering the video signal. That was going to be making it less sharp than it is now. So even though it's dark, I mean, it looks really good. And we bring up the multi-burst. And I guess for now, what I can do is I can just turn up the picture and turn up the brightness. Yeah, I mean, I don't really know if this is any sharper than it was. It's really hard to tell because now that I have the brightness turned up with the blacks, they're kind of gone to gray. So we're losing definition over in this section. It has to be sharper. Oops. There's no way that it's not sharper than it was. Right, so I think what I need to do, I put the brightness back to what it was. I think what I need to do is just install probably a jumper link where that inductor was. In fact, I could have just done that. I think if I just put a jumper link over that inductor, it would have disabled that entire thing without me desoldering it and damaging it. So that should restore the brightness back to the way it was. The 4.7K resistor that's right here, I think has to do with just the noise shaping or whatever filtering is going on. It allows some of that signal through. I don't know. There's magic going on because it's analog video, and analog video has got magic. And I'm not good at magic, but I'm trying my best. Okay, I went ahead and I jumped over that broken inductor, so hopefully the picture's brighter now. And I also hooked up a toggle switch. So theoretically, I can switch between the chroma output from the Jungle IC and my external chroma output. So right now, I only have the Luma connected to the main board on the TV. So let's turn this on, and let's see if the TV is working or bright or what's the deal. Okay, it is on. Okay, good. Well, the image is definitely much brighter. Looks a lot better. Let's switch over to the regular color bars. Yeah, okay, that looks good. Excellent. So just jumping over that inductor totally works. I'm just going to check the settings here. Okay, sharpness is set to 25, brightness is 25. Is that a good setting? Yeah, it's a good setting. I think everything looks pretty good. Let's go back to the multi-burst. which is this. Yeah, that is much sharper now. Definitely removing that inductor, jumping over it has produced a much sharper image. This is really clear now. I actually kind of worry that if I just put normal composite video into this, we're gonna have a lot of dot crawl since I removed that inductor. All right, well, it is what it is. First of all, the toggle switch, let's see if I toggle it, if anything happens at all. Oh, we got a little flash of something, but the video that's going into the set right now only has monochrome, there's no color information. So the fact that there was a little flash, I think that was just nothing. Okay, I'm gonna plug the chroma into there. Oh, that looks horrible. How odd that with the cable plugged in there, it looks like that. But flipping it the other way, looks like that. Okay, well, clearly we're hooked up the chroma connector properly. If I flip the switch though, okay, we're losing color information. There's some bleed through though, obviously. Just touching the wires, it kind of comes and goes a little bit. Okay, well, either way, it looks good. And when I go back to the multi-burst, there's no color fringing or anything, so that's excellent. And this one again looks really good. So I'm seeing sharp lines there. The color looks good. Everything looks really good. Now the question is, I need to feed composite video into here and we need to see potentially how bad it looks now that I remove those components. So let's switch back to there. I'm gonna unplug the chroma. I'm gonna flip the switch so we have nothing. And I need to move the cable on the back of the test pattern generator over to the composite video output, because right now I'm on the Luma chroma output. Oh, it doesn't look so bad. It doesn't look so bad at all. There's a little bit of a dot pattern there. That's from that trap being disabled. But if I flip the switch, then we get a little bit of chroma information leaking through. I think I'm just not using shielded cables and whatnot, but you can see the dots there a little bit more clearly. And there's the color information overlaid on top of those dots. Okay, so there's the trap enabled and those dots disappear. In fact, if we turn off the chroma, you can see that it's pretty much smooth now. And we turn on the trap and now we get the dots. And the picture's a little bit brighter as well. But the question is, when we hook up other types of sources like a Commodore 64, are we gonna see a lot of dots? And what exactly is it gonna look like? That'll be something that I'm gonna have to test. Incidentally, if you're seeing sort of these wavy patterns in the picture, that is coming from the fact that this is a relatively low-res CRT and that dot pattern is interfering with the phosphor spots. If we turn this off, those waves are still there. It's literally the dots that make up the chroma information and the phosphor dots just aren't lining up perfectly, so you get sort of those very high-frequency waves and they're not really straight due to deflection differences, stuff like that. It's too bad there's not a way for me to electrically enable the trap filter. Obviously we can do it with a command. We don't know what the command is, but there's an I2C command to turn it off and on. If we could somehow turn it on while in composite video mode, it would create a nice, perfectly smooth image, and then we can switch to S-video and then we get that nice, super sharp image. If I switch to the multi-burst, it's gonna be very much dot crawly, messed up. You know what, that doesn't even look that bad. I'm shocked. That doesn't look that bad, disabling that extra filter stuff. I mean, sure, there's dot crawl happening here, but that's just how it is. Okay, well, I think at this point, I need to wire this up in a kind of permanent way, AKA drill some holes in the side of the TV for the switch and the extra RCA jack for the chroma input. In the end, I'm gonna have to use the front input for the Luma input, when you toggle this to separate mode, or that will just become the composite video. Unfortunately, there's actually 3 spaces on the board for RCA jacks. It was originally for video and stereo audio, but this case doesn't have a hole for the extra jack. If I install it, I could drill a hole in the front of the case and then we could use that for the chroma input. Problem is, I feel that that's kind of unsightly and ugly compared to just putting one on the side. Of course, the other possibility is to install it on the back of the set. The problem with that though is that if you took the back off, all the wires would be connected and I'd have to come up with a way to easily disconnect it. I really should buy some connectors. Maybe I have some. I'm gonna look to see if I have some. I need how many wires? The switch needs 3 wires, and then the RCA jack needs 2 wires. Yeah, let me see if I have some way to connect this. I just don't think I do. Okay, in the end, I decided to put the switch and the jack on the back of the TV. I really could use some better connectors. So I ended up using these 2 little harnesses, and I used shielded wire to run under the board, so it goes around the front, and there's a couple holes in the board, so it goes through that, and one is the input and one is the output. Output being the chroma information coming from the jungle IC, and the other one is the input going into the jungle IC. And what I need to do is, when I pull the back cover off, you just have to connect up the 2 connectors. They are different, so you can't mix them up. Inside of this little bundle, there's the 75 ohm resistor for termination. I should have put it on the back of the monitor, but I didn't. And there's also the capacitor that's required, the 0.1 microfarad for the chroma signal that's going into the jungle chip. I think this should completely work. So I'm going to put the back cover on, not put the screws on, but just sort of reassemble it, and we'll give it a test. And on the back of the set, there's the RCA jack. It's right next to the RF input. This is for the chroma signal. And then we have the toggle switch to go between the internal chroma decoding, so composite video, where you flip that, and then it should be external chroma. Okay, power is applied to the set. Let me turn it on. All sounds normal, so that's good. Hopefully it's okay. And there we go, we have nothing hooked up right now. So the yellow cable goes to the test pattern generator, and it is composite video. So we'll pop that in, and it looks like it's already in the correct setting. There we go, we have correct color. That is good. And if I flip the switch on the back, there we go. We have a little bit of bleed through, which is exactly actually just like the Commodore 1702. It has a little bit of bleed through even when it's switched off. Switch it back on, looks fine. There's obviously dot crawl, but we knew that was going to happen. That's because, of course, that trap is disabled in the service menu. All right, so now what I'm going to do is I'm going to plug the Luma signal into the front of the TV. There we go. We got a nice sharp image without any dot crawl at all. I'm just going to adjust the focus a little bit. And this is now the Luma signal. So let's plug this into the back. And there it is. We have nice clear signal. And if I flip the switch, actually, we have quite a bit of bleed through, don't we? So much so that even when it's in the position for really the internal chroma, we still have chroma bleeding through. But that is definitely the correct setting right there. But if I flip the switch now without the cable connected, it doesn't do anything. And on this particular pattern, things look amazing. All of these look great. There's no dot crawl, no weird colors. Everything is super sharp. Color looks good. It looks pretty much as good as it can look. I went and grabbed the Retro Famiclone. This thing has composite video output. It also has S-video. So first we're going to start with the composite video. And let's see what this looks like now. Okay, I think I have the switch in the wrong position. There we go. Okay, so one thing that is for sure, we definitely have a lot of dot crawl. I'm talking about a lot. Let's see if I get this dialed in. Yeah. Okay, well that doesn't look super great. I mean, it's fine. It works, obviously, but there's a lot of dot crawl. And this is, of course, with just regular composite video when I have that trap turned off in the service menu. And there we have it. The audio is working. Actually, I'm noticing that there's a bit of a band in the middle that definitely wasn't there when I had the test pattern generator hooked up. And I have to think it's because I kind of cheated a little bit. And on the chroma input coming from the jungle IC, which is what we're looking at now, right? Because we're looking at the internal color decoding. It originally had, I think, a 68 picofarad capacitor, and I ended up putting a 0.1 microfarad because I'm just sharing the same capacitor that I'm sharing on the chroma input from the external jack. And I think this bit of a green band in the middle is gotta be that. I guess I'll know for sure if we switch over to Luma Chroma with this NES and then see how that looks. Okay, so first we'll switch over to Luma output on this console. So there it is. Not seeing any discoloration or anything either. And we'll flip the switch and we'll plug in the jack. Okay, well that looks perfect. And I don't see that green band in the middle anymore either. Oh, that's interesting. So I've kind of made it worse, actually. I mean, it certainly looks good, though, doesn't it? Well, with an NES, yeah, I mean, this looks fantastic. You know, I gotta say, with a low resolution set like this, you don't necessarily need to have it hooked up through RGB, because S-Video can look nearly as good. Maybe it would be a little bit sharper through the RGB, which we haven't even done that mod to this TV, if it's even possible. But this sure looks great. It's extremely sharp. And of course, because I removed those extra components on the Luma input, on the video input that is, well, it looks really good. Let's turn on the trap filter, see what that does. So we're going to go into service mode. There it is. There it is. It's S16, which we're on now. And there's the trap filter on. I mean, on the NES, that literally makes no difference. I don't even see a difference. I'm sure there's a slight sharpness difference. We know there is. And if we were looking at something that had a lot of high resolution graphics or something, you might be able to notice it. But certainly on the NES, yeah, I just don't see it. Don't see it at all. Let's look at these, the dot pattern on the door here. Okay, yeah, it is there. It's visible. So with it off, the trap filter, this definitely looks a bit better. I can see these pixels in the stonework here look a little sharper, and it definitely dulls it when you turn that on. So it looks better with it off through the S-Video input, that is. But boy, does it look a billion times better than it ever did through composite. Of course, now composite looks terrible because I kind of ruined it. And if we switch back to composite, there it is. You wouldn't even notice there's any kind of issue here other than the excessive dot crawl. But it was really obvious that there was a problem over here in regular Super Mario Brothers. Yeah, I can see there's a bit of an issue in the middle, but when I turn on the notch filter, that goes away. That blue sky looks pretty much uniform, at least to my eyes it does. All right, I'm currently on composite video, not Lumachroma, and the notch filter is turned on, and it looks just fine. Absolutely fine. Don't really notice any negative ramifications of before I did these mods. So I suppose it just means that if I'm going to be using this monitor for actual use with S-Video, I need to go into the service menu and make that change to turn that notch filter off to get the most sharpness. Obviously, we can still use the Lumachroma, it's just we don't benefit from all the additional sharpness that we would otherwise get. All right, I brought out the Apple IIc because this is going to output high-resolution monochrome video, and we should really be able to see the fact that the 80-column text is going to be more readable when I have that notch filter turned off. So here we are just in normal, well, let's see if there's even color. Color's not really working. There we go, flip the switch, and now it's working since this is the internal color decoding. Now, one thing is that text is not particularly sharp. So I'm going to turn this off, and we're going to go to service mode, and I'm going to turn off the trap. So currently it's on. You can see the text is readable. It's just a little bit fuzzy. Oh, wow. There's a big difference when you disable that. So now the text is far sharper. And if we exit out of this and we do PR number 3, so this is going to be 80-column text, and it's not terrible. It's readable, barely, but readable. But if we turn that trap filter back on, yeah, that makes it a lot softer. You can just see like the X's and the question marks become much harder to read than with it off. So this is similar to the 1702 monitor. When you flip that switch to separate mode, it disables that trap, right? Because it's a physical device, it grounds it out. For low resolution CRT, which is what this one is, because it has the large dots for the phosphor, it just means you can never have that clear of text. But that's a whole lot more readable with this trap disabled than it is with it enabled. And I have to say, if this was my only television and this is how I had to use it, this is usable. It is actually usable in 80 columns mode. And of course, in 40 columns mode, well, it's a lot better. It is a lot. That text is nice and clear. Now, of course, if we bring in some color graphics, well, you can see that artifact color on the Apple II is made up of vertical lines, and that's what we're actually looking at here. You can see it pretty clearly that all those squares have vertical lines in them. If we reboot this machine and we go into total replay, let me just get the camera adjusted here. This will be able to show us full screen color stuff. And yeah, you can see all the vertical lines. So the TV has enough resolution to resolve those vertical lines. It's just, unfortunately, this is one of the side effects of when that filter is turned off, the trap, then obviously you can see all these vertical lines. Now, I have an Apple II on the desk, so one thing we have to do is we have to run Fat City. Let's see if we can find that. I know it's on here. There it is, Fat City. Look at those lines. So many lines. Yeah, this S-Video mod is definitely compromised because of that. Ah, yes, look at that. Look at that. Awesome, just awesome. If you were using this TV with your Apple II, would you use it in this mode where you see the vertical lines and the colors? Or would you go back to the softer mode and give up the sharp text just to get rid of those vertical lines? Just for comparison, I will go and make that change so we can see that difference again. There it is. Yep, pretty much gets rid of all those lines. And if we run Fat City again, this is how it looks with the trap enabled, set to 0 in the service menu. Yep, there it is. Okay, time for some conclusions, so to speak. One thing I can say for sure, when I look at the schematics here, without a doubt, these two components, that little capacitor, 33 picofarad, and the 68 microhenry inductor, that without a doubt did soften and filter the video. And with the trap enabled, set to 0 in the menu, it looks pretty sharp. But I'm going to say that this probably eliminated a little bit of the edge on pixels and things like that, and probably reduced dot crawl ever so slightly. So the designers of the television decided to add this in. I think you're pretty safe just removing it if you want to add the extra sharpness to this TV no matter what. And then, of course, going into the service menu and turning off that trap, at will also just increase the sharpness. Even if you don't add S-Video, but you just feed Luma into the front of the TV like we're doing with the Apple II, well, that's going to give you much, much, much sharper text at the expense of seeing those vertical lines or the dot crawl if you're watching or using something like an NES console. What if we go into the menu and we turn the sharpness down? So sharpness is currently at 25. What if we turn this all the way to minimum? Well, it takes away, I'd say that actually makes the picture blurry. I think sometimes sharpness controls don't add any blurriness. They just basically remove this peaking, which is what the sharpness is. This actually seems to kind of go too far and make it blurry. If we exit out of this and we just look at some text, we can kind of get an idea of what I'm talking about. If we turn this all the way down, yeah, it just kind of blurs everything a little bit, which I think seems a bit, I don't know, artificial, so to speak. But if you turn this up too much, what it ends up doing is adding some artifacts around the letters, which is what it's doing when it's turned up to 37. That's too high. Probably a more acceptable level would be, something around here, like at 17. So I might want to go into the service menu and adjust the sub sharpness control to make the middle section 25 look more like this. This looks about right, if you ask me, just from my eye of looking at a lot of TVs over the years when it comes to setting the sharpness control. We should still have the ability to see 80 column text okay. Yeah, it's not great. What if we turn the sharpness up? It doesn't really make it that much more readable. So again, I think where I had it was probably a good setting. Okay, so it's been a few hours and I've been playing with the TV hooked up to the Apple IIc, and it's been working just fine. Considering there was supposed to be a fault with this TV, certainly nothing has ever really shown up. I swear I saw for a split second vertical collapse, but that never really came back and I've never been able to catch it on camera. So I don't know what could be causing that. Maybe there's a fault in the jungle IC or the vertical deflection IC, but it's weird because it just seems to be working perfectly. So I don't really necessarily think that might be the problem. It's probably a bad connection in between those two. Maybe a surface mount chip just has a slight crack, a cap, who knows what. But the problem will have to get worse where it'll be more consistently doing it for me to try to troubleshoot. Right now it's so intermittent that's not really something I can fix. As for the S-Video mod, I didn't really know how this was going to go, and I'm happy for the most part with the way it turned out. If I only use this TV in S-Video mode, it's great. I just turn off that trap in the service mode and it's nice and sharp and looks great. But definitely going between composite video and the S-Video mode kind of sucks because composite looks really not great with all the dot crawl when you have the trap disabled. The compromise would be to enable the trap, but then you're going to have softer S-Video than you really ought to. The whole point of S-Video is to have really sharp, nice video, and having that trap enabled kind of ruins it. Now, as for RGB mods, I know people are going to ask, why don't I RGB mod it? I have to be honest, I don't have that many things that use RGB. I mean, the Amigas do, of course. There's an Amiga 500 sitting right here, but I have Commodore 1084s to use with those. No, they're higher resolution anyways. If you're talking about a TV like this that's low resolution, it's not really suited for use with high-res RGB computers. It's really better suited to game consoles. And game consoles that have RGB also pretty much always have S-Video. And on a low-res TV like this, S-Video really is going to look most of the way as good as RGB. I know people are going to be in the comment section, no, it's not, that's not the case. RGB looks so much better. I don't think so, not on a 13-inch TV like this. Composite video looks pretty bad with all the dot crawl and the softness because you need that trap filter enabled. But once you disable that and you go high res like I've done with this and you give it S-Video, it's gonna look pretty good. And that's without trying to do any mods to intercept that on-screen display RGB stuff and combine it. And the mess of wiring that I have in here now would be so much more if I was trying to do RGB on this. For me personally, I'm just gonna get a lot more use out of a monitor like this with the high resolution composite video and the high resolution S-Video input. I just have so many more things I could use with it, like the C64 and all sorts of other game consoles that can output S-Video and will look good on this TV. And there we have it. That's the little S-Video mod for this little sharp 13-inch television. So if you enjoyed this video, me fiddling around with this TV, then thumbs up would be appreciated. But if you didn't, you know exactly what to do. A huge thanks to my supporters. They make it possible to do this full time. Without them, I'd have to get a normal day job, and I can't imagine doing that. I love just fooling around with this old junk down here in the basement. And I think that's going to be that. So I'm going to be back on the Lisa soon. I'm just finishing up on all this mail call stuff here. And then I can get back to the Lisa, and then there's just so much more to work on. But it was really fun little diversion to work on this set. And yeah, I really like these little sharp sets. They look cool. And now this thing is that much better. And I have a feeling lots of people are going to ask in the comment section to investigate the RGB mod. And maybe that'll be a part 2, actually. Now I think about it, it'd be kind of good to know at least once and for all if the RGB on this thing is capable of taking an analog signal, or really it's just in digital mode and it's stuck there and that's all that we can do with it, just digital. Anyways, that's gonna be that. So stay healthy, stay safe, and I'll see you next time. Bye-bye.